So over here, what you have is a solder ball. Everything here is based on hints. We're always working with hints. We don't know. There's no certainty. We also have a solder ball over there. Maybe I'm losing my touch, but I don't see any. Oh, that's a big solder blob. And again, this is right by CPU vCore. Yeah, this is not very nice. That's a lot of solder balls for this board. Oh my God! Look, another one. Oh, look at this cap bank over here. Why, God! Holy look at that one. There's a solder blob on literally every single... Oh, what the wow! I haven't done this for a while, so I almost forgot how much Apple products suck. Hey everybody, how's it going? Hope you're having a lovely day. So today what we're going to do is we're going to fix a MacBook. I find that sometimes my natural meditative state comes about when I'm fixing a MacBook, and we're going to see if that helps with any of the lovely, lovely mail that I have here. You know what? I'm just not going to depress myself by even getting into it. So, let's take a look at what it is that we have under here, shall we? And see if there's anything we can do to make it work again. Click on. Good little camera. All right, so what do we have here? Well, what do you know? It's a MacBook. It's a MacBook. So, how would we get started with this? Well, anybody here remember what it is that we used to do back in the day when we used to fix MacBooks? Well, one of the things that you do, first thing you should always do, is you should unplug the battery. One thing that I also notice here is that this battery cable is unplugged, and somebody messed up this little latch on the board over here that would allow the battery cable to connect, which is really, really lame. Very, very lame. I don't understand why somebody would do that. That's not a nice thing to do to the computer. That's not a nice thing. It needs that so that the battery can speak to the computer, because the battery can't speak to the computer, it's not actually going to work. But I still tend to unplug it just out of a sense of over caution. So first thing that we always do is we unplug the battery, and then we plug in the charger so that we can get an idea of how much power it is that the board itself is taking, because that often actually gives us an answer as to what it is that our problem is. You know, when you kind of have an association, once you spent 2 hours trying to fix a problem and you finally figure it out, one of the things that it makes sense to do is to just kind of take a basic little peek around and see what it was that it was doing beforehand, and then make an association. Okay, so when the board is doing X, the problem is Y. You make a nice little table like that for yourself. So this is 5 volts, 0.01 amps. That's no good. Now, typically that tends to mean that PP3V3_G3 hot is missing, or that a CD3215 is not working properly. I'm not really sure which of the above it is. Not really sure what's going on with this, but we're going to open it and see. And I'll have all of you here to follow along with me. Isn't it fun to be able to follow along with me? Yep. One of the things that is kind of a constant in the world, regardless of what's going on, it's that MacBooks will need to be fixed, and people out there will need to know how to fix them. That's why we do these videos, so that all of you will know how to fix MacBooks and have some understanding of how to make them work again. The world needs more people that are willing to take things that don't work and make them work again. Willing to kind of dig into a problem and figure it out rather than just give up and toss it out. I always feel like I'm going to rip this little cable over here. It wants to rip so badly, but I don't give it the satisfaction of that. So as you can see, when I plug it in, it's stuck at 5 volts. Now that seems kind of low for a laptop, right? It needs to be 20 volts. It should be 20. 5 volts. USB-C can provide 5 volts, 9 volts for phone fast charging, 20 volts for a computer. We need 20. And in order for the computer to tell the charger to give it what it needs, it has to talk to the charger. And there's a chip that's going to do that. So the charger is going to speak to the USB-C port controller on the board. And if you want to be able to find where that is, say you got the board view software in front of you. Sweet mercy. Okay, here we go. Let's say you have the board view software in front of you. You have this connector. So as you can see, if you just follow it along over here, you have the charger going to the charge port. And that is going to a connector on the motherboard over here. And that connector is J3300. If you want to know where to get a schematic, you can use a website called google.com. Or you can go to apple.com and ask for them once right to repair has been passed. So we take a look, And now there's a bunch of different lines over here, all different types of stuff, all sorts of ins and outs and things. And I'm kind of a curious guy. I like poking around where I'm not supposed to be poking around. It's just kind of part of who I am. And one of the things that I do is I may just poke around at stuff like this and try to see where things go. And as I'm poking around, seeing where things go, one of the things that you may come to is CC1Con and CC2Con, which is where that is going to be going to a transistor, which then goes over to this chip over here, U3200. Now, what is U3200? That's a good question. If you take a look at what U3200 is, U3200 is called a USB-C port controller. This is the thing that's going to talk to the charger and tell it, hey, I'm a MacBook. I'm not a phone. I want 20 volts. I don't want this 5-volt garbage. Give me some real power. And this chip is powered by its in. So over here, you have all these different things: GPIO, IC2, C, USB TP, Ripida, HIVGate, SenSep. I mean, you take a lot of time to learn what all this stuff is. I2C data line, SPI clock, and I know what these things are, but you may not. One of the things that's, you kind of have to guess what all these things are. And over here you have VIN. That's not the identification of your vehicle. That is voltage in, what's going to allow it to turn on. And on MacBook schematics, typically the voltage that's going into a chip that's going to allow it to turn on is going to be located on the top. And when I follow that back, it shows up as PP3V3 underscore G3 hot underscore RTC. So, well, let's take a look and see if that power rail is present and where it comes from. Because I can't blame any of these chips for not working. Can't blame the chip if it's not actually getting the power that it needs to turn on. So all these different points in the board are points that I can check. Now, when you take a look around the board, what I like to do is I like to find the biggest, chunkiest point, or something that's obvious. Show me something nice and chunky that I can easily find. And I'm just going to choose this capacitor that's right under this CD3215 over here, and I'm going to turn on the multimeter software, and we are going to measure what it is we get over there. So you can take your black probe, and your black probe is going to go on ground, and then your red probe is going to go on on where it is you're looking to measure. So we're going to do that over here, and we're going to see what it is that we get. So you just got to put the black probe over here, and the red probe is going to go over there. And let's see what it is that we get. 0. Okay, that's not nice. We get 0. Now, well, there's many reasons a power rail cannot be present, right? So we got to try and figure out what the reason is that power rail is not present. Maybe it's not being created. Maybe the chip that's not supposed to be creating it is not being told to create it. You never know. Maybe it's actually creating it, but it's being shorted to ground by something. Maybe it's cut off. It's in this part of the board over here, but it's not on that part of the board over here because of a cut via. Well, there's many different things that can cause that. So let's try and figure that out. So what I'm going to do here is I'm going to have one probe on ground and the other probe on PP3V3 underscore G3 hot underscore RTC. And what I want to do is I want to try and see if it is shorted to ground, because if it's shorted to ground, that would be the explanation, one of the explanations as to why it's not working. And that's a very common thing that can happen. So we are just going to do this, and we are going to measure and see what's popping. Okay, so it looks like open line, so it is not shorted to ground. So we're going to have to do a little bit more research over here to figure out what it is that's going on. Yeah, 5 million ohms. That's not it at all. So the question I would have is, where does PP3V3 underscore G3 hot underscore RTC come from? So we're going to have to kind of explore the schematic over here and figure out what's going on. I don't give a fuck about Elon Musk's live stream. Fuck him. I don't care. I don't give a fuck. I see Elon Musk showing up in my chat over and over and over again. I don't give a shit about him, or Mark Zuckerberg, or Jeff Bezos. I don't follow the lives of billionaires. I don't care. I don't care. Okay, so let's figure out where PP3V3 underscore G3 hot underscore RTC is coming from. And now the thing is, here's a part that kind of confuses a lot of people. What confuses a lot of people is when they need to figure out where something is coming from versus when it's going into something. So here, PP3V3 underscore G3 hot is going to become our PP3V3 underscore G3 hot RTC Mesa. So this is a current sense resistor. You have to know what all these different circuits do or have a slight idea of what these things are doing. So this is a current sensing circuit. So what it's doing is it wants to sense all of the current that's going to be going to, I guess, a Mesa chip. So it's going to go through this resistor. That's PP3V3 underscore G3 hot underscore RTC feeding something that's not PP3V3 underscore G3 hot underscore RTC where it's being created. So let's continue. This is PP3v3 underscore G3 hot going into a chip. Now you may ask, well, why do you assume it's going into the chip and not out? Because it says in. It says in. This says out. So that's not it. I want to see where it's coming from. Again, remember what I said. Usually when it's on the top of a chip, that's where it is powering that chip. So I'm pretty sure that that's powering this chip. That doesn't seem like it's it to me. We're going to keep going. This seems like it powering the keyboard. Again, does the keyboard make a power rail, or does the power rail power the keyboard? Again, some common sense there would tell me that this is not what I'm looking for. Again, I'm looking for where this is created. Looks like this. Again, what do we see over here? PP3v3 underscore G3 hot. It's going on top of the chip, VDD. Anytime you see something like VDD, VCC, VN, that's voltage that's going into the chip. That's not what we're looking for. Here we go. Okay, what do we have over here? V out, 3.3 volts. Bam. Over here, it looks like the output of something. And this looks like the input of something. This is where it's coming from. It's created by U6903. Now, there's a couple of things that I'm going to want to look for in this section. There's a couple of things that we got to look for. Now, over here, first thing is the chip being asked to turn on? And that's a serious question. So we have this is an enable pin. So what this does is it tells the chip, turn on and make this power out. This R6907. So I want to see if it's being told to turn on. Second thing I'm going to want to do is see if it's actually getting its voltage in. So this chip is going to take its voltage in and turn it into voltage out. Now again, we don't just replace the chip because the power rail is missing. It's like replacing a light bulb before checking to see if there's power going to it, or before checking to see that you turn the light switch on. You want to see if you turn the light switch on, which is EN. You want to see if you have the voltage in, and that's that. So, what we're going to do over here, is we are going to check if we have the enable present, because we need the enable. And we're also going to check what we have on input. So input is going to be on R6900. So let's check what we have on R6900. R6900. Where are you, R6900? The Paul Daniels software used to actually surround it so you could see where to... Ah, there it is. I don't know. For some reason, I didn't see that as easily as I used to. I'm trying to figure out a way to frame Paul Daniels for that because that was clearly my mistake. But I feel like I should be blaming him for some reason. The software should have been able to blink or something if I didn't notice it. I don't think that was very noticeable. Has the color scheme on this changed, or is it just me? I want to blame Paul Daniels for this. That just doesn't seem like... Let me try that again. That didn't seem very intuitive. Right-click R6900. Yeah, that didn't seem very intuitive, did it not? So I'm over here. I'm going to click R6900. Now the hard part is going to be locating where this individual resistor is. So it's next to a big capacitor on the left, and it's got like a vertical capacitor on the left, 2 horizontal inductors on the right. So what do we have over here? I don't want your money, Guzelstrad. I want you to pay attention. I get your money if I fix this board. Okay, so let's see. So I believe it's this. So let's see. What do we have over here on input? Okay, so we don't have any input. So I can't really be blaming the chip. Now again, a lot of people, what they would do is they would blame this chip and they would say, I'm missing this power rail. I need to replace this. No, it's not getting its input. It's not getting its input. So what we're going to do is we're going to figure out what this is over here. ppvin underscore G3 hot underscore P3v3 G3 hot RT. That is confusing. That is a mouthful, is it not? That's really weird. So I don't think that that's the name of that rail. I think that's the name of the rail after it passes through something else, like maybe a current sense resistor. And that seems to be what it is. So if you take a look, R6900, which feeds the chip that's making PP3v3 underscore G3 hot underscore RTC, which is required for us to get 20 volts instead of 5 volts in the charger, which is getting by powering the CD3215, which is not on, is going to come from here. So where do we... Let's take a look at R5420. R5420. Aha! PP bus. So this is interesting. So on the 2019 machines, or the 2018-19 model, PP3v3 underscore G3 hot does not come first, and then PP bus G3 hot second. PP bus G3 hot comes first, and then PP3v3 underscore G3 hot underscore RTC comes second. See that? Sequence is very important. So if you only watched older videos on the A1707 and A1706 and A1708, you just learned something, because usually PP bus is not the rail that comes first. But in 2018, It is. Different design. Things change. So we need our PPBush G3 Hot over here, because PPBush G3 Hot is going to become PPVin G3 Hot P3 over there once it goes through this current sense resistor. And again, the purpose of a current sense resistor is to be able to measure everything going to a specific point. So everything beyond this point is going to be measured by U5420. It's going to see the difference in voltage from here to here. Use that to calculate the current that is being passed to PPVin G3 Hot P3V3 G3 HRTC, which is going to be used to create PP3V3 underscore G3 Hot underscore RTC. That's a fucking mouthful, man. So let's take a look at what's going on. PPBush G3 Hot. So where can we find PPBush G3 Hot? Where do we see that? Ah, we see that on F7000. A nice, big, hearty, chunky fuse. So, well, let's see. Do we have any voltage there? Well, we go to measure. We go to measure. And what do you get? 0.0000. Well, that's no good. Okay, so, well, same things are going to apply here. Is there an enable? Is it being told to turn on? Is its input there? And above all, is it short to ground? Well, there's one way to find out. We've got a multimeter. We have Paul Daniel software that'll show the meter on the screen. So what we're going to do is use it. So what do you get? Oh, what do you know? There's a short circuit to ground. Oh, that's interesting. Okay, it looks like we have a short circuit to ground on PPBush G3 Hot. And let's make sure that this fuse still works, and the fuse does still work. So it looks like, again, there is a short to ground on our PPBush G3 Hot that we are going to have to figure out. Well, luckily, that's easy enough. We're not going to be reballing a PMIC or replacing a PCH or have a dead T2 chip. Usually, that winds up being just a bad tantalum capacitor, and oftentimes you can actually see them because they physically break, and those are usually easy board repairs. So what we're going to do is we're going to see if we can see something that looks damaged physically and hope that that makes things easy. I don't know if that's going to be the case, but you never know. And if that's not the case, then we're going to inject a little bit of voltage in. And after we inject some voltage in, we'll try to figure out what gets hot using the OWI method. I would usually use the thermal camera, but I'm using Linux, and nothing works with Linux, so I cannot use the thermal camera that I have with Linux because, well, Linux. There's no software for it. I guess there would be if I coded it myself, but I'm not smart enough to do that. I'm barely even smart enough to use software that other people code for me, like Paul Daniel, so how would I be smart enough to code my own? I am not a smart person. You just think I'm smart because I know how to do something that you don't know how to do. And that is one of the biggest fallacies in the world, when people call people smart or geniuses because they can see that they know how to do something that they don't. It's one of the coping mechanisms people have. It's a coping mechanism. You see, if you say, instead of saying, that's a normal person that knows how to do something I don't, it's like, okay, well, you can learn it. Whereas if you say, oh my God, that person's a genius, they're so smart, what you're doing is you're putting them above yourself to an extent that it kind of disables you from believing that you can actually accomplish what they've accomplished. Which is why it's very important to me to always maintain on this channel that I am an idiot. I am not going to give any of you an excuse to not learn or at least try to learn how to do what it is that I do. And that's the idea. Get more people fixing things, get more people learning, get more MacBooks out of landfills. Even though a small part of me would kind of like to throw MacBooks into landfills, that is an internal conflict, and that does not really serve my customer. So I don't see anything that's obvious here. Do you guys? You let me know if you see something that kind of sticks out there. I don't see anything that sticks out yet. Okay, I do see some minor imperfections here in manufacturing. I paid $5 to tell you it's pronounced like the animal gazelle. Thank you for the great content. Thank you for reminding me that I don't know how to speak English, but I appreciate it. Thank you very much. I hope you are having a lovely evening, and I hope you are learning something from my horrible board repair. So over here what you have is a solder ball. Now, I don't believe that this solder ball has anything to do with my problem, but what I'm going to do is I'm going to take a mental note. Solder balls often happen when you have too much power going through an area or a chip die. That's a current sense resistor, so I don't think there's any problem with the current sense resistor. I would imagine just take note that maybe more power than what should have passed through that at one point in time. I'm just going to make a mental note of it. I'm not going to write it down. It's not worth writing down. It's just worth making a mental note of it. And that resistor just seems to be for VCCIO. That's a part of the CPU that gets powered up before CPU vCore gets powered up to allow it to negotiate how much voltage it wants from the regulator, which means, Okay, so that's just this one little sign that CPU may have been gonzo. Again, it doesn't necessarily mean that has to have happened. It's just a hint. Again, what we do, everything here is based on hints. We're always working with hints. We don't know. There's no certainty. We also have a solder ball over there. Again, for all this could just be poor manufacturing. Again, we are looking at an Apple product here, and they are not well manufactured a lot of the time. So that could be the case. You really can't know. So that is for PP3v3 underscore G3 hot underscore RTC. But again, it's not going to be anything around this area that has a problem because as we went over previously, the issue was with PP bus G3 hot not being present, not with this. So there's really no reason to blame this. So we're just going to continue going. And again, we might as well get rid of all these solder balls along the way. Really, if we're going to be looking through the board, we might as well get rid of all these little signs. I don't want the machine to leave here just, one problem solved. I want it to leave here actually better than it was when it left the Foxconn factory or wherever the hell that they make this thing. Every single one of those solder balls that I see, I don't know, it just kind of symbolizes like the tears of a crying child worker that's working all day long to pump these things out so that Apple stock can go up. Okay, so there's nothing visual. Maybe I'm losing my touch, but I don't see any. That's a big solder blob. And again, this is right by CPU vCore. Yeah, this is not very nice. That's a lot of solder balls for this board. I'm used to seeing maybe 0 to 1. Like 3 of them is something else. Yeah. Now, again, it could not be a manufacturing thing. That could simply be something that occurred while it was, while it was failing, while PP bus G3 hot was shorting to ground. And again, the reason I'm spending so much time looking for it is because I have an incentive structure to not solder a wire to the board and figure it out. Oh my God! Look, another one. Oh, look at this cap bank over here. Why, God. Holy look at that. One. There's a solder blob on literally every single... Oh, what the wow. I really did. I haven't done this for a while, so I almost forgot how much Apple products suck. Oh my God. What is this shit? Okay, I don't think I could use this as a diagnostic tool anymore because they're everywhere. There's too much of it. Oh, man. I really didn't plan to say something about Apple in this video. I really didn't. I was just going to fix a board. Oh my God, this is so fucked. Okay, so all those solder blobs are by caps for NAND power. Oh, no. No. I hope you backed up your data. Oh, man. Okay. That's because the drive is soldered to the board. Oh, jeez. Oh, okay. So many solder blobs. Okay, so it looks like we're going to have to do this the old-fashioned way. Stop being lazy, as they would say, and start actually doing some work. There is a quality shortage going on here, Mr. Kopaz. There is indeed. And we are going to figure it out. We're going to fix it, though. So what I'm going to do is I am going to turn on the power supply. And once we turn on the power supply, what I'm hoping is that we can inject a volt into the board and something will get hot. And once something gets hot, we can run something called the OWI test. I'm going to put this at 1.2 volts so that if it's going to the CPU, I'm not going to kill anything. Okay, So what we're going to do here, take the ground. Ground can honestly just go to really any ground point on the board. And then we're going to take this, and we're going to solder it to where PP-D3 hot is in the board. Now what we're going to do is we are going to find, the first thing we have to do is figure out why the power supply is on, software is on. So we are going to send some power through this fuse, and we're going to want to see what comes out on the other end of it. What gets warm? What gets warm? I don't know about solder glue. I've never used solder glue in my life. A laser soldier sounds scary. If they make soldiers that can shoot lasers out of their eye, like Superman, we're fucked. Good enough for rock and roll. It's a temporary joint anyway. Okay. And how many amps does it take? Oh, my ground wire came off. No worries, no big deal. We're just going to reattach the ground. Ooh! 4 amps. Okay, 4.5 amps, 1.2 volts. We're probably looking at 5 watts. That's going to be nice and warm. I'm hoping it's not the CPU for obvious reasons, because if it's the CPU, then, well, this goes to Chris. So this is something that doesn't... This is not going to need a thermal cam. This is going to be obvious. Let's see. I think it's something over here. Yow! Okay, so it's something over there. The OWI test has been vindicated. So we're going to look over here. All right. Now I'm going to turn off the power supply, or I'm just going to unplug something, and we are going to put some alcohol over there. Again, I can't use my other thermal camera because I am using Linux right now. It uses some weird Chinesium software that I'm very lucky that I even have this thing working on Windows, much less Linux. So we're just going to take some alcohol and toss it on the board in this area, and then we're going to see what gets warm. Well, wherever the alcohol evaporates, that's typically where our problem is. Now again, this is something that is not as good as a thermal camera. If you're looking at an iPhone board and you're injecting like 1 volt and it's taking 100 or milliamps or something. But for 5 amps at 1 volt, it's going to show up and become obvious very soon. So 3, 2, and okay. Now do you see what I see? There's a discolored capacitor over here. And you see how there's 4 caps and one of these caps is not like the other? So there's 2 things that you may notice about the capacitor all the way to the right. The first thing you may notice is that it has an internal bleeding. See that? Internal bleeding. And the third is that it has some scuff marks over here that this one, and this one don't have. So I'm going to take a guess that it's you. I'm going to zoom in real quick, and let's just do that again. Confirm my theory. Yeah, that cap over there looks like it's our culprit. See how it's the one to dry off first before the others? So what we're going to do is I'm going to knock that cap off the board, and I'm going to see if that fixes the problem. Now, this is where, again, not doing this for a little bit got me screwed up, because when we looked over the board, I said that I didn't see anything that looked visually damaged, yet that's obvious. That's clear visible damage. I mean, I should not even have to take out a multimeter to fix this board. The fact that a multimeter had to be taken out to fix this board, or a schematic, is just a sign of my being out of touch with this as a profession. Because this, like you could see it clear as day. So when here's the thing to note. You notice how when that capacitor gets knocked off the board, it's no longer taking amperage. But if I were to have it make contact with the board again like this, it does. So this is the cause of our short. And when we knock it off the board is going to work again. So I am going to put another capacitor there. We're going to have to be very careful soldering it in because we got a BGA chip over here, so we're going to have to cover that with something. I typically tend to use iPhone shields or a box cutter to cover that so that this does not get heated when I'm heating what I want to heat. I only want to heat what I want to heat. I don't want to lower the life of any of those BGA chips by heating things I'm not supposed to heat. That's one of those things that you'll never really know until a customer comes back 9 months later with an SSD that doesn't work, or 2 years later with an SSD doesn't work. And admittedly, the customer may not even know that the reason it didn't work is because of how you put too much heat on a BGA chip next to it while you were doing the original job. So these are all things that you got to think about, and you have to be very careful. You can't remove solder pads like that there are certain devices where you just can't do that. They'll come off the board immediately. You need to know the device you're working on in order to do things like that. So when I do things like that are kind of rough, it's because I've worked on this board like 1,000 times. So I know what I can get away with on this board versus what I can't. But there are many other devices where the solder pads would immediately come off the moment you did that. Also, you see this over here, the old, well, you can't see it now, but you probably could if you rewind it. The old capacitor piece came off over there. Yeah, so the old capacitor, the little piece that was left of it, came off the board, and that is that. So that is the end of that little thing. Yes, we did, GM TAC. Yes, we did. That is... Okay. So, we do this. And over here. So we've removed all the old solder, or depending on your pronunciation in this chat, soldier, soldier. I don't know why people call solder soldier. The solder doesn't fight for you. And we are going to take our shield and put it over the chip that's next door. And while we're heating this, we don't want to heat what's under there. So we do this. Just a small precaution. Now granted, there's a good chance that you're not going to do damage if you are careful with your hot air, where you're pointing it, if you're careful with the airflow and the temperature that you use, then you don't have to worry about that very much. But it's always good to have just an extra level of protection. Don't be that guy that says, I'm going to pull out. Like, just don't. Have a condom. You know what's even better? You have a condom, and she's on birth control. Like, that's a winner chicken dinner right there. You want as many forms of protection as is humanly possible. Unless you want a kid. But again, that's your business, not mine. I'm just fixing your MacBook. I'm not here to give you reproductive advice. But it's good to have redundancy. Okay. So, we are going to take a capacitor. We are going to put it right over there. And then this board will turn on. You'll see 20 volts in the charger, 500 milliamps, and victory. Now, flow into place. Oh, that is smooth and satisfying how that flowed into place, wasn't it? That was beautiful. We're going to make it look like stock. This is going to look like factory. It doesn't matter how shaky my hand is. It doesn't matter how inaccurate I am with how I put it down. But at the end of the day, you have little techniques, little things that make it easy to make things look beautiful. So we got a little bit, just enough flux there to be able to flow this into place. Yeah. All right. So we're going to let this cool down for a moment and remove the shield that I had that was covering the BGA chip to the side. Put this donor to the side as well. Now, with what's over here, what we're going to do is we're going to see if it takes 20 volts. That's a little. So what do we have? I'm going to guess 20 volts, 500 milliamps. What do you all say? You have a different signature? Okay, 200 milliamps, that's a different signature. 20 volts. 20 volts. Come on. Yeah, over 500 milliamps. It's booting, baby. Yeah. All right, that is beautiful. Look at that. So that is a fixed MacBook right there. So on this machine, it's really weird. I think I stopped doing board repair videos when we started fixing more A1989s. On this one, it looks like PP-Bus G3 hot. It shows up before PP3v3 underscore G3 hot underscore RTC, which is needed for the CD3215. So they changed the order a little bit. But that shouldn't mess you up too much. As long as you're open to following the flow of what's going on in the circuit, that's not something that should really be a big issue for you. You see that this is a rail that's needed for us to get 20 volts. This is what's needed for the CD3215 to be able to speak to the USB-C charger. Okay, what power all turns it on? Let's find that. Okay, why is that rail not present? Is it shorted? Is it not being enabled? Is it missing its input? This is all stuff that's in my free board repair guide, which you could find in the description down below. 150-page guide to motherboard repair, going over all the basics and the troubleshooting tactics. We go up the chain. We see, oh, it's PP-Vin, PP3v3, that's missing. Oh, where does that come from? That comes from PP-Bus G3 hot. Okay, that's missing. Why is it missing? Short to ground. Let's find the short to ground. We found it, we fixed it, and it works again. This would actually be considered a fairly simple board repair in contrast to what's usually in Paul, Chris, and Dan's queue, which might just be why I recorded it. But you'll never know that because this is going to get edited out of the main channel video. Like magic. No one will ever know. All right. That's it for today. And as always, I hope you learned something. I'll see you all in the next video. Bye now.